I'm very excited to announce our investment into Inngest today. And to help us tell the story on what makes the company so interesting, I'm joined by their co-founder and CEO, Tony.
Hello, thank you so much for having me. And excited to work with you.
Thanks for joining us. I want to get into a lot of stuff today. And in many ways, the Series A announcement is probably the least exciting thing to talk about. What gets me most fired up is hearing Tony and team kind of peel back the curtain a little bit on their longer term strategy, what they're most excited about, and where the company is headed. Namely, becoming the platform to build reliable and scalable backends. I've seen it, developers have seen it. There are a lot of tools and there's been a lot of development in the front end world. It's very easy to build and scale a React app, but it's much harder to do that for back-end systems until now with Inngest. We'll get into all of that. I want to start with more of the origins, where you started out, what Inngest started as, and I think that dovetails nicely into where you're going and where you're headed. But just rewind the clock back for us to the early days. You started Inngest as a workflow engine.
Yeah.
What is a workflow?
Yeah.
And how did you make those easier?
Yeah. I'll set the scene with some context. Before Inngest, I used to run engineering at a healthcare company, and healthcare is super workflow driven. So basically, you write workflows, you write step functions that model what happened in the real world. When a patient does X, you must do Y and Z in your system. And that sort of stuff is really, really difficult to build. Typically, it requires you to have a bunch of queues, a bunch of maybe things like Kafka, a bunch of workers, and it takes a long time to build up these systems, which are then super brittle, really hard to change, really hard to test. What, honestly, should have taken a day to build would take like a month, maybe more. And that was after we had the foundation set. It took like 6 months to build those foundations. So realistically, long term, I wanted to have a simple API that compresses all that complexity into just, when this happens, I want these steps to run. I want to wait for this other thing to happen. And then these other steps should run. And those should be reliable. So if things are down, if services are down, like health insurance companies' APIs are not the best. If they fail, the step should retry. And so a workflow is simply basically a step function. And it automatically manages the retries, the reliability, the durability, the observability for you. And you use a really basic SDK and really basic API that gives you all of that power out of the box. And suddenly you don't need to think about these sort of infrastructure problems. And what would take months ended up just taking a day, which is super exciting. So we started out as a platform for workflow orchestration. Notice that if you took a look at the ecosystem, you had to build this on servers. You had to deploy a bunch of infrastructure. You had to deploy queues and events at the same time. So you're paying for 2 sets of almost event streams. And you couldn't do this in a really easy way to scale deploy on serverless. So there's this like gap in the market in which you could say, I want to run reliable background services on something like Lambda. And that was previously impossible, just sort of used for API endpoints. And if we could make that a thing and make this broadly applicable to everybody with a really simple SDK, suddenly it would become really, really easy for you to build these complex backend services.
Yeah, makes a lot of sense. I mean, in many ways, as the applications have got more and more complex, kind of like the backends that we need to support them have gotten more and more complex. And one of my favorite hot takes about AI is the reality is an AI agent is really just a workflow, kind of dressed up as something more than that. An agent is going to plan a task and then kind of like execute a set of steps within that task to kind of like durably complete an overall function. So how have you seen the concept of a workflow or the idea of a workflow change now that we're entering this kind of AI agent era? And not to lead the witness, but that could be things like, now we have probabilistic workflows versus deterministic ones, right? Like just big picture for us, how have workflows changed, if at all, now that we've entered this era of AI agents?
Yeah, so there's your basic deterministic workflows that we're doing for years. And we've seen that, and that still happens. When a sign up happens, you might want to send their account to 5 different places. Or when a user requests a refund, you have to do 5 separate steps. And then you get the AI workflows, which are super interesting because, like you say, non-deterministic, a little bit more complex, but realistically, it's just a series of steps. And I think like the interesting part about AI workflows in general is that the way you choose to orchestrate them becomes even more important. So, for example, we've known for a long time if you can't see what's going on in your orchestration system, you have no idea really what's happening. Makes sense. In AI, it's incredibly important to record every input, every output, every tool use, every decision that happens at every step of the workflow so that you can understand what's happening. And then theoretically, if you would like to, be able to say, I want to replay this workflow from step 10 with a different prompt so that I can understand what happens if we do these sort of things and have like evals across your workflows in a way. And that orchestration becomes super important because the outputs of the AI and the inputs that go into it are essentially derivatives of your workflow orchestration platform. And if you have these as separate systems, it can become very hard for you to understand what's happening in these non-deterministic sort of workflows. So the non-deterministic thing is super interesting. We've definitely seen that sort of explode. And we've also seen this like middle ground of sort of state machine-ish, do these steps up until this condition is met, and then continue on with the workflow, which gives you a little bit more control. It's really interesting, but ultimately, same set of problems.
Yeah.
Do some steps in a row deterministically. If things retry, continue on or replay that step until it succeeds, and then continue on with the workflow.
Yeah, that's fascinating. I mean, in many ways, this most simplistic view of a workflow maybe 5 years ago was when a user signs up, send them a welcome email. If they haven't entered a credit card after one day, just send them a reminder too.
Yeah.
When they're on day 6 of a 7-day free trial, send them a reminder that their free trial is about to run out.
Yeah.
And there isn't really a lot of optimization that you have to do in the middle of that workflow because you're just defining each step. But I think what you said was very interesting. Now that you have probabilistic systems executing these steps, there's going to be a huge amount of alpha and value into optimizing every individual step along the way because there's so many ways to define, was this step successful? And it isn't just binary.
No.
It can be good, but it could also be better. And so how do you constantly iterate the workflow and every step along the way? Because if you have 10 steps, and you make every step 10% better, those just compound through to the end state.
Exactly. And that compounding cascading of errors is really important, especially as you have more and more steps. And additionally, if you're building these steps in your workflow platform, it just makes sense that, for example, a tool call might not be an LLM call, it might be some random code. And so if you have this built into your orchestration platform, the orchestration platform can take care of tracking the inputs, the outputs, the tokens, the models, the output responses, the tools, plus the execution of any tools and code that it needs to do the thing. Then it can show you all of this information so that you get basically a burn down of these are my users that are costing me the most amount of tokens. And that's essentially insights over your orchestration data, which you should be able to get from any of your orchestration platforms in general, and we give you out of the box. So I think there's not just this whole non-deterministic, deterministic part of it, but as you scale these systems, you really need to understand what's happening inside your orchestration platform, and the insights that you can derive from the workflow itself are super important in the day of AI.
Amazing. I want to get into the meat now, kind of how Inngest is evolving and what the next 5 years will bring. We've talked a lot about this. You've launched some of this messaging today as Inngest becoming the platform to build reliable backends. We've also chatted about this. Like the term backend is very broad. Are you building a database? Are you building a Kafka replacement? Are you building a state management machine? Like what is a backend in the context of what you're making easier at Inngest?
Yeah, for sure. So taking it back to the whole step.run APIs, if you want to build something that's reliable or scalable, there's traditionally been a few ways to do it. And the first is add a queuing system so that you can do retries on your async jobs. The second is add events so that you can do some pub/sub stuff with Kafka or MSK or any of the additional stuff. And then as you build these out, your complexity explodes. From day one, you've already got a database. You've already got some APIs. But when you hit scale or when you hit additional complex use cases you need to build into your product, these sort of things become a real challenge for you to add. And then often require you to re-architect basically everything, which is really tough. And that's why it took us 6 months to initially build the thing at my previous company. If you were to get the same step APIs that you get to build reliable, scalable systems using Inngest inside your API endpoints as is from day one or day zero, you wouldn't have to re-architect anything. You could say, when this API endpoint is hit, I want to step.run some auth, I want to step.run a DB query, I also want to return this data from the user. Easy. You get APM, OTel, metrics, replay, debugging out of the box. And then when you want to do something in the background, you can step.defer it into the background, for example, and it will spin up a thread, make sure that that thing reliably executes in the background. If it fails, we'll re-enter that particular API endpoint and only execute that step, which is kind of amazing. And then you don't have to think about queues, orchestration, workflows, or events at all. The SDK just kind of does it for you, and you're truly, in a way, infraless, so that you only have your database, the APIs, and us to tie everything together, and everything kind of just works without you thinking about scale.
Yeah. Make it a little bit more concrete. It's hard to build and scale backends from kind of a hobby project to something real in production.
Absolutely, yeah.
What are some of the first pain points developers run into as it relates to scaling their backend?
Yeah. Failure rates, cascading errors, lack of observability, difficulty of scaling, containers crashing. Those sorts of things are really, really difficult to deal with and end up with you re-architecting to make things sort of more Inngest-like. And if you could get that from day zero without any infrastructure for free using the SDKs, it would make a lot of sense for you to just deploy this stuff from day one, and you're good to go.
Yeah. Let's talk about, you've talked a bit about it, but stepped out run. If I use that function in my work today, what superpowers do I get out of the box immediately?
Yeah. So step.run is like one of the key concepts of a workflow, of a step function. And it's basically a code level transaction. So anything you do in that code block is going to retry if it fails. And then once it succeeds, it'll only run as close to exactly once as possible. So you're going to get things like retries. You're going to get a bunch of replay, OTel, metrics, performance, and observability built in. And you essentially don't need to do anything but add step.run around the code that you want to execute. Everything else happens automatically. And when you use this in API endpoints, there's no latency hit. It sort of happens in the background. And you kind of get everything out of the box.
Yeah, that's awesome. Maybe switching gears a little bit to kind of serverless environments and serverless endpoints, right? Many developers out there today are already using AWS Lambda. They're using Cloudflare workers. They're using Vercel. How do they think about building differently, if at all, in a world with Inngest?
Yeah, so it's super interesting because we have a bunch of customers on Vercel or Lambda or Cloud Run or Cloudflare. And previously, before they used Inngest, they could essentially just build their API endpoints, which if they failed, the user would smash the refresh page and then hope that it succeeded. And so you'd have your front-end APIs on these serverless platforms and your back-end systems on traditional servers or VMs or EC2. If you adopt Inngest and when you add the step.run APIs to your SDKs, you can suddenly do all these stateful things in Lambda. You can suddenly do all these stateful things in serverless functions because if the step.run fails, we're going to retry it automatically. And if you have 5 steps in a row, we can make sure that each of those 5 steps gets hit and we inject the state directly into those functions. So it turns out a lot of people could just throw away a bunch of complexity when it comes to Terraform or their cloud deployments, save a bunch of money by throwing everything into Lambda, and then treating their infrastructure as basically ephemeral. All they need to do is send an event over to Inngest and we'd run that function in the background automatically, which is super powerful and solves a lot of problems.
Yeah, which reminds me also of another thing. When I went out and talked to a bunch of users, one of the things people highlighted, kind of time and time again was, hey, with Inngest, we have flexibility in where our code runs. Explain that a little bit more to the audience and why that's important.
Yeah, so step.run is kind of interesting because we abstract the state for you. When a step runs, we take that state, we commit it to a state store, and then we rerun the function and inject it back in so that step doesn't rerun. And that means that if you have a function that's 10 steps and it's like going to take over a day to finish, you can rewrite that function from Golang to Python or TypeScript, and you can deploy it from Vercel to AWS, and it will pick up where it left off automatically because our system injects the same state into the same function, even if it's a different language on a different host. And that means that if you're, for example, one of our customers, Avalon Bay, who does, a large amount of real estate in America, and they're dealing with all of these leases, they can take some of their foundational infrastructure that's on Azure and then shift it over to AWS in sort of a lift and shift approach without really doing too much effort. It just kind of carries over where it left off, and there's no risk for you to move compute from A to B because the compute doesn't matter anymore. What matters is the function going to run the same way? Are we going to inject the same state? does it pick up where it left off? And that's what we give you.
Yeah. So maybe a little bit of like a harder question because it's a broad question.
Yeah.
But fast forward a few years, if your vision plays out and we kind of get to this zero infrastructure world where as a developer, I'm not thinking about my back end at all. What are the implications of that? What does that enable me to do? And why is that important?
Yeah, a few different things. And I'll talk about it from the context of AI and then just traditional infra. In the context of AI, I think you can see things moving a lot faster nowadays. And that's definitely visible at the front end because you can sort of vibe code a decent UI, which is great. But it's pretty hard to vibe code a scalable backend that will work reliably in every case. And if you could use a simple API like step.run to abstract the entire infrastructure and make this really easy, it would suddenly be really easy for you to also vibe code your backend, but scalable, reliable, to a point where you could write this sort of stuff in an hour and it would be good to go. And that's super interesting. So we basically want to compress the complexity of all the infrastructure that you need to run something reliably in a backend and give it to you out of the box. So that's the AI component. The second is we have an interesting approach in which, there's RPC to basically call a function, but you can also send events over to us. And when you send an event over to us, maybe one function runs, maybe 10 functions run simultaneously. That event is a fact about something that's happening in your company. So it might be a user sign up, it might be a payment, it might be health insurance was submitted. But because you send those events to us, we also store them so that you can replay functions on failure. If you have a bug and you want to replay all of yesterday's functions and you know that it was released at 12 a.m., you can choose to replay all of yesterday's events up until 12 a.m. through one function, for example. That's super cool because then you can start getting a bunch of insights, metrics, observability data, not just over your functions, but over the events as well. And then you suddenly sort of have this space in which you've got all of these events, all of these facts around your business. You've got all of these dashboards and metrics and queries that pull out all of these facts. You can give all of these facts to your users, whether that's real-time analytics or if it's facts about what they did, audit trails, or just like memory for AI. It's all present automatically in the way that you've built your systems just because you added step.run to your APIs. And that's super powerful because then you don't need to build too much. You can mirror this in ClickHouse and keep all of that there for when you want to do all your OLAP queries for your business stuff. And then you get a bunch of the real-time APIs out of the box for your product.
Yeah, awesome. Whenever I hear abstraction, I also hear trade-offs, right? What you get in an abstraction is generally less control to kind of like fine-tune and tinker and make every piece of what you're ultimately abstracting perfect for your use case. Generally, small companies like abstractions because it's easier to get going and you can just press a button and you go. Large companies are more complex, more bespoke, and they like the ability to kind of like tinker and fine tune and, twist this knob, twist that knob. How do you think about those trade-offs? And why should large companies or big workloads trust Inngest with an abstraction layer?
Yeah, that's a super
and maybe the premise
question.
of my question is wrong.
Super interesting question. And you're totally right to the point where we've had to invest so much time in different like control mechanisms to say, when you send 10 events, I want to batch them into one function run. Or I have 100,000 users, each of them are running AI requests, and I want to make sure that each user can only do 5 things at once so that one user doesn't have all of the capacity of your system. We spent so much time building that into our queue, which means we had to build our own queue and do all these associated things. And so super aware of the complexity and the sort of tweaking that you need to do at scale. I think like the foundational thing is building this stuff is, fun to a degree, but ultimately so incredibly time consuming and complex that if you were to spend 9 months building a version of what we give you, you would have something that maybe works. Which is okay, but maybe works. And it wouldn't have any of the things that you need to run it in confidence at scale. And so when you adopt something like us, you generally speaking can just build a lot faster. And I think nowadays in particular, building a lot faster is even more important because this is something that I think you and I have talked about and you make a really, really solid point. Iteration speed is super important and moats get smaller as the ability to build more develops in a shorter amount of time. And if other people are building faster, the inevitable thing is like, at some point they're going to catch up, or at some point they're going to outdevelop you. And so there's this sort of impetus for you to need to do the same thing. And so we have a bunch of larger companies that are like public and like, oh, we also need to ship faster. This complexity is way too much for our engineering team. We need to adopt Inngest because our team are genuinely suffering. And if we adopt Inngest, it's going to simplify everything from our cloud deployments to the way that we run Kubernetes to the way that we run Kafka. Everything just kind of gets simpler. And I think no matter the scale of the company, developers ultimately care about the developer experience as well. The technology that we built is pretty cool. People really like it when they use it as well. And there's this sort of like nerd sniping that happens when an engineer discovers something like, oh, this is amazing, I want to use it for everything. And so like there is always some sort of trade-off with abstractions, and you will always get more control. But then again, why use kube?
Yeah. No, I mean, it's
why not mess with your kernel and then deploy everything using your own orchestrator? I think ultimately it just doesn't make sense, and you want to focus on what gives you the value, which is building what you need to build.
Yeah, I mean, speed and iteration speed has never felt more important. And so many companies now, I go into a board meeting and even just like the concept of a product roadmap, I don't want to say it's getting thrown away, but you build a product roadmap that has kind of short, medium, long-term goals, and you're kind of building towards something that you might release a year, 2, 3 years from now. One of the inherent challenges of like a roadmap is it forces you to think in a certain way, and you get stubborn about building towards that roadmap when the world is changing so quickly that what you should be building actually changes. Yeah. And so there's freedom to not, to having a broad picture roadmap that you want to ultimately build to, but being not dogmatic in it and being intellectually flexible enough to switch. And then, and then it all becomes about iteration speed and how can we iterate quickly? How can we ship products quickly? Yeah. And how can we reduce a lot of the other complexity, the back-end complexity, to enable us to do that? Yeah. And so I think you put it well, which is Inngest becomes a core enabling pillar to let these companies, and specifically AI companies, ship and iterate really quickly.
Yeah. Without any of the complexity or worrying about infrastructure. And that speed, that sort of abstraction, the compression that we do is particularly interesting because then you can build what, like we were talking about, takes months in an hour. And that is super exciting. It solves a lot of problems for people. And ultimately, if that exists, it's sort of an inevitability. Because would you want to spend 2 months building something when you could spend a day building something, get it to market quicker, test, and then end up building the right thing in a couple of weeks versus a few months to a year, which is a really big deal.
Awesome. I mean, when we've talked a bit throughout this whole interview around how you're kind of moving towards this like zero infrastructure type of future where you don't even need to think about it. Another product that you're launching today is Insights. Talk to us a bit about Insights and why those matter.
Yeah, so we sort of mentioned this when it comes to AI, that the AI being a derivative of the workflow engine itself and the orchestration platform, in that each particular step generates inputs and outputs and, the structured data from AI. It also should have the metadata around the tokens that was used, the user that was calling it, the model that you used, and so on. Maybe latency, time to first byte, and so on, or time to first token, I suppose. All of that's important from the workflow level. And then you've got all the events and the facts around what's happening. Like this user made these 4 orders, which then gives you maybe long-term memory over what your users are doing. If you can combine all of those into one platform that gives you real-time metrics and insights over your function runs, you can then directly in your orchestration platform say, here are my top 10 users, and here are the token counts that they have cost me directly in this platform. And here are the top 10 workflows that have failed, for example, or that didn't give users satisfactory results. And then you can also query your particular facts to say, here are the last 4 tickets that the user has submitted, because you've just sent events over to Inngest and we store those tickets for you and you can query them. That's kind of cool because then you can start building all of this sort of abstraction over just facts about what's happening in your system automatically without you having to add any infrastructure to your platform. You're just saying, when this happens, do this. Oh, and also, I want to query the last 10 times that this particular thing has happened. And they should both be there in the same platform. So Insights is this like super cool ability to do almost all of that without you worrying about anything, I suppose. Ideally. Yeah. And that's the whole infraless approach. You should get the best of everything with as few compromises as possible so that you can just build the right thing from day zero.
Yeah, that's awesome. I want to give you the opportunity to highlight some of the ways your customers are using your product. Because I think there are a lot of like really interesting things the world might not be thinking about that they'd kind of like love to mirror. You know, I think about talking to users and hearing how they put Inngest in front of kind of like their rate limiter for their API calls, or load balancing this API, this AI provider from that one based on availability and latency. I mean, again, don't mean to lead the witness, but what are some of the ways that you're seeing your customers use Inngest today?
Yeah, so it started off pre-AI a couple of years ago with the whole, we've got some complex insurance flows and we need to submit some documents and we need to gather evidence and all that sort of stuff, which are really complex step functions that would be traditionally very hard to model in code. The most interesting ones nowadays are definitely the AI use cases. I think super friendly with this company called Outtake, who I think they also just did their Series A last month. Really, really good people. They're a security company that run on top of Inngest. And essentially they just observe facts about what's happening in the world, about who's talking about you, about all these different things that are happening. And then they give you a whole bunch of security insights and prevent attacks using AI as the sort of core underlying decision making. I don't know their code. I don't see how they do it, but they run all of their workflows on top of us. And it is incredibly interesting to at least see their use, the flow control, the events, the facts, and how things happen. Really, really, really cool company. And there's a bunch of others that are like that. Another one is like this CRM company, Day.ai, who are particularly interesting from like a sales point of view, because I feel like AI and sales, I think everyone knows this, go hand in hand. And there's been a lot of SDR stuff. There's been a lot of email outreach stuff, which is also cool and useful. But from the CRM perspective, having your meetings, emails, notes, public information about all these people that you talk to tied together on one platform is really, really cool. And we basically power all of it, which is interesting. So it's kind of essentially TLDR, really interesting to see how people adapt so they can build all of these complex processes basically from the first week of their company's existence without worrying about infrastructure. And that is really, really, really amazing. Lots of AI, real-time stuff, and then your regular product flows. Like we mentioned Avalon Bay. If you want to lease from an apartment, sure. That's a flow that's already existed for like 10 years, but we make it better for them.
Well, this is a lot of fun. I mean, it's clear you're kind of on your way to being a core pillar of not just the agent infrastructure stack, but kind of like more broadly how applications of the future are built. And we're very excited to be along for the ride with you, and can't wait to see what you guys accomplish over the next few years.
Thank you so much. We're incredibly grateful and really lucky to work with you as well. You've done a lot of good things in the past, and we incredibly grateful and lucky. So thank you so much.
Yeah, let's go.
Yeah.